Hi everybody, so I did a short recently on a magnetically assisted Stirling engine. This is a few seconds long. A lot of people said, can you go into more depth? And I thought, well, yeah, okay, no worries at all. It was a bit short, so this is a video about more detail on that short. Now, when I was thinking about doing it, of course, I held this up as an example of a Stirling. It's a low thermal difference Stirling engine. And I've made this into a generator, and I noticed I hadn't actually done a video on the generator conversion. Now it's really simple, so I'll give you a close-up of it so you can see how it's made, and it needs no more explanation than that. So there it is, and it's pretty obvious what I've done, really. I've just glued a load of little neodymium magnets on the actual wheel there, and here I've got a very small coil. That coil I got from a solenoid, and of course when the thing turns it generates like any generator, and we get a pulse current out of there. So dead simple to actually make. Okay, well, let's quickly go through how a Stirling engine works. Now, we've got an enclosed vessel right here filled with air. When we put that on a coffee cup, of course that air gets warm, and we know from our gas laws that when the air gets warm, what we get is a build-up of pressure. Now, of course, it's in an enclosed vessel, and the only place that pressure can go is right here. There's a hole in the top. That hole in the top has a piston. As the pressure builds up, it forces the piston out. Now, the piston is linked here with this crankshaft, and as that piston gets forced out, that crank pulls on the displacer and pulls the displacer up, shifting the air. Now, the air gets shifted between the hot side and the cold side. When the air is on the hot side, of course, it gets warm, and we get an increase or an attempt to increase volume, and so an increase in pressure. When the air is on the cold side, it does exactly the opposite, and that decrease in pressure forces the piston to go around again. So the displacer here does nothing more than occupy space. Because it occupies space that was previously occupied by the air is forced to move between the hot and the cold side and get hot and get cold, and that is what operates the piston. And of course the piston is attached to this crank, spins the flywheel, flywheel's got magnets on it. The force originates from the temperature difference, because remember, the temperature is what causes the gas to expand in an enclosed chamber, exerting a force. So these things work on temperature difference. The greater the temperature difference, the greater the force is going to be, the more you're going to get out of it. If you're working on very low temperature differences, then you're not going to get a lot of force because you're not going to get a lot of pressure. The reason these things work at low temperature is because, well, they've got a large surface area, so they can pick up the heat as quickly as possible. They have a large volume here in the displacer cylinder, so that increasing a small amount of that volume has a larger effect on a small chamber, which is why the piston is always small. So those factors govern the amount of power you're going to get from something like a low thermal difference Stirling engine. Now, they're not terribly efficient, and this is a toy, so it's not brilliant. And it loses efficiency all of the time. And one way that's going to lose efficiency is in the crank system. That's quite a big loss, actually. And you have to remember that air, which is the working fluid in here, is in fact an insulator. So it doesn't heat up and lose its heat instantly. It takes time, and that time means that there's an amount of dwell, an amount of time you need to give it in order for it to be able to do that. It also will do that quite naturally, and it creates a pressure wave, which is why thermoacoustic engines work. So you can use that pressure wave to get rid of this displacer crankshaft. If you do that, you've created something called a ring bomb engine. A problem with those is that they need tuning, and that can be quite tricky to actually do. So in a practical sense, how can we get rid of this crankshaft and not rely on tuning the pressure wave in order to make a low thermal difference engine more efficient and work better? Well, we came up with that idea, obviously, and that was pretty simple. It was to stick a magnet on the bottom of the piston. Because, of course, as the magnet approaches something, remember that magnetic force is the square of the distance, then that attraction goes up. If you can get it to a point where it's just attracting the displacer, of course when it gets to that position, the displacer will move, forcing the air to move, then the piston will continue its route, pulling away from the magnet and the displacer. When it gets high enough and that force is now less than the weight of the displacer will drop. So we can do that if we use a magnetic linkage between the displacer and between the bottom of the piston. Of course, this won't do it because the piston's actually to one side. So what we'll get is that going on. What we need to do is move the piston to the center of the displacer and put a tiny magnet on the piston. We also need to put something onto the displacer. Now a magnet will work just well enough, north-south, north-south, or we can just put a tiny bit of steel on that displacer and that's going to be attracted to the magnet. Once we do that, of course, what I've described as a magnetically assisted ring bomb has been created. But not really. Strictly a ring bomb works on pressure waves, but the magnetic assistance allows you to make that engine without the crankshaft attachment to the displacer and without having to rely on tuning it for the pressure wave that would otherwise be set up, because they can be a bit tricky to do. Once you do that, of course, you've got a nicer chamber, because one thing is it's got a hole in here for the crankshaft of the displacer, and that's going to be air leakage. With a magnetically assist, of course, that hole's gone. You've also lost the inefficiencies on the crankshaft itself, and of course power is being taken from that, so we get a better machine. If you then do what I've done here with this magnet arrangement and coil arrangement, you have yourself a magnetically assisted ring bomb Stirling engine that is a generator. So I've gone into much more detail of that. I understand that it's more detail than most people would want, but the short was really just a bang, look at this. This is a bit more detailed. If I've left anything out, then please do ask in the comments or comment in the comments and I'll do my best to answer. But equally, I know there's a lot of people out there who know a lot more about Stirling engines than I do, and I'm quite sure they'll help out as well. Anyway, hope you enjoyed the video. I hope it helped. Thank you very much for watching.